Hello, my dear students, with you, Mr. Mahmoud Shirbini, your science teacher, and today we'll explain lesson 3 in Unit 2, the radioactivity and nuclear energy. In this lesson, we will talk about main points as nuclear energy, the radioactivity phenomena, the uses of nuclear energy, and the harms of radiations. At the beginning of this lesson, we must know some important informations we have studied before in grade 7 about the components of atom. We know all that the atom consists of two main things. Atom consists of two main things as nucleus and electrons revolving around the nucleus. The electrons have negative charge while nucleus contain two things, protons and neutrons. The protons have positive charge and the neutrons have neutral charge. So we can conclude the charge of nucleus. The charge of nucleus here is positive. Why the charge of nucleus is positive? Because it contains positive protons and neutral neutrons. Neutral mean no charge, okay? Neutral. Neutrons mean no charge, okay? So the charge of atom is neutral because it contains negative electrons and positive protons, while the number of negative electrons equals the number of positive protons. Okay, so now the components of atom. The atom consists of nucleus and electrons revolving around it, while nucleus consists of positive protons and neutral neutrons. Okay, now we will know the difference between the chemical reaction and nuclear reaction. The chemical reaction, we know all that occur between the electrons or occur between the atoms depend on losing or gaining electrons or sharing. But nuclear reactions occur due to the change in number of protons and neutrons in nucleus. It occurs between the nucleus of the atom. But chemical reactions occur between the electrons of the last energy level. Okay? So the difference between chemical reactions and nuclear reactions, the chemical reactions occur between two atoms, while one atom lose or gain or share the electrons, and the nuclear reaction occur between the nucleus of two atoms to produce a new element. Okay, the chemical reaction it changes the number of electrons, while the nuclear reaction it changes the number of protons and neutrons. Okay, okay. So now we will talk about the nuclear energy and what is meant by the nuclear energy. The nuclear energy is stored inside the atom nucleus, and it takes its name, the nuclear energy, from this that is stored in the nucleus. Okay, the nuclear energy is originated due to the presence of nuclear binding force. We know all that the nucleus contain protons and neutrons. The protons have positive charge and the neutrons have neutral charge. While the protons have positive charge, so it must be a repulsion force between the positive protons and each other. And there is a nuclear binding force that bind the components of nucleus together. Okay, so we have here inside the nucleus two things. Number one, repulsion force and attraction force. Repulsion force between the protons or positive protons, and attraction force between the protons and each other, and protons with neutrons. Okay, so the nuclear energy produces due to the presence of nuclear binding force between the components of nucleus. Okay, so the nuclear energy stored inside the atom of the component, and it originated due to the presence of nuclear binding force, and the nuclear binding force originated from the nuclear binding force is responsible for the attraction force between the protons and neutrons and protons with each other inside the nucleus. Okay. Okay. And now we will talk about the radioactivity phenomena and who discovered it. The radioactivity phenomena discovered by the scientist Henry Becquerel. He discovered the emission of radiation from the uranium element or unseen rays from the uranium elements. He named this phenomena with the radioactivity phenomena and called the uranium element with the radioactive elements. Okay, he called it with this name because he emits radiations or emits unseen rays that can or have the ability to penetrate solid objects. Okay, so the radioactivity phenomena discovered by Henry Becquerel by discovering the emission of unseen rays from uranium elements. He called these elements with radioactive elements and called this phenomena with the radioactivity phenomena. Okay, we have two types of elements: stable elements and unstable elements. This stability depends on the number of neutrons. We know all that the number of uh, neutrons equal mass number minus the atomic number. If we have the element X, any element, it has atomic number and mass number. Atomic number, which represents the number of electrons or the number of protons, and the mass number represents the sum of protons plus neutrons. Okay, so we will have element like carbon C612. We can conclude now the number of electrons, protons and neutrons. The number of electrons here is the atomic number equal 6 and the number of protons equal 6 because the number of negative electrons equals the number of positive protons. Okay, and the number of neutrons equal the mass number minus the atomic number. Okay, so 12 minus 6 equal 6. Okay, here the number of neutrons equals the number of protons, so this atom is called stable atom because the number of neutrons is equal to the number of protons. Okay, we have another type of elements as it called the unstable elements. Okay, the unstable elements have or contain a number of neutrons more than the number required for its stability. It contains a number of neutrons larger than the number of protons with large value. Okay, like uranium, radium, cesium, polonium, rubidium. All of these are called radioactive elements. Okay, we can now define the radioactive elements as they are the element whose atoms nuclei contains a number of neutrons more than the number of required for its stability. Okay, so we can define the radioactive elements as they are the elements whose atoms nuclei contain a number of neutrons more than the number required for its stability. Okay, now we can conclude that the radioactive elements or the stability of the radioactive elements depend on the number of neutrons. If the atom contains a large number of neutrons more than the number required for its stability, this atom or this element is called radioactive elements and this unstable elements. We have many examples for radioactive elements like radium, uranium, cesium, polonium and rubidium. Okay, these elements are unstable elements and must get rid of excess energy to reach to its stability state. Okay, they lose the excess energy in a form of radiations, as we have three types of radiations that the atom nuclei of radioactive elements emit it. Okay, number one, alpha particles, number two, beta particles, and number three, gamma rays. So the atom nuclei of radioactive elements emit three types of radiations, or one of them, or two, or the three with each other. Number one, alpha, beta, and gamma. Okay, so the process which the radioactive elements emits radiations like alpha or beta or gamma, this process is called the radioactivity phenomena. The radioactivity phenomena, which Henry Becquerel discovered it from the emission of unseen rays from the uranium elements. We can now define the radioactivity phenomena as it's a spontaneous decay of the atom nuclei of some radioactive elements that present in nature in attempts to achieve more stable composition. They emit radiations like alpha, beta, or gamma to reach its stability state or to get rid of the excess energy. Okay, we can define the radioactivity phenomena as it's a spontaneous decay of the atoms nuclei of some radioactive elements that are present in nature to achieve more stable state. So this radioactivity phenomena is a natural radioactivity. We have two types of radioactivity: natural radioactivity and artificial radioactivity. Okay, now we study the natural radioactivity, which explain the radioactivity phenomena. Okay, the radioactivity phenomena, we can define it again as it's a spontaneous decay of the atom nuclei of some radioactive elements that are present in nature to achieve more stable state. Okay, so why the nuclei of the radioactive elements are unstable? We said that the radioactive elements are unstable because they contain a number of neutrons more than the number required for their stability in a form of excess energy. So the radioactive elements must get rid of the excess energy in a form of radiations like alpha, beta, and gamma rays. Okay, so we have now three types of radiations: alpha particles, beta particles, and gamma particles. This phenomena of the emission of radiation from the radioactive elements is called the radioactivity phenomena. Radioactivity phenomena is an example of natural radioactivity. We have another type for the radioactivity which is called artificial radioactivity. The artificial radioactivity which occur or which study the nuclear reactions inside the nuclear reactors or the nuclear bombs. So we can define the artificial radioactivity as it's the radiation or nuclear energy that is released during nuclear reactions or nuclear bombs. Nuclear reactions that is done in the nuclear reactors or the nuclear bombs that is used in the military purpose. Okay, so now we have two types of radioactivity: natural radioactivity as the radioactivity phenomena, and artificial radioactivity, which represent the radiations or the nuclear energy that is released during the nuclear reactions that occur in the nuclear reactors or the nuclear bombs that is used in military purpose. Okay, so now we have two types of artificial radioactivity. Number one, reactions can be controlled, and number two, reactions can't be controlled. They can be controlled, which done in the nuclear reactors, while the can't be controlled like the nuclear bombs. Okay, so we have two types of radioactivity or artificial radioactivity. Number one, reactions can be controlled, and reactions can't be controlled. Can be controlled at the nuclear reactor that is used in generating electricity, while the reactions can't be controlled like the nuclear bombs or the reactions that occur in the nuclear bombs. Okay, so now we will talk about the uses of nuclear energy and how we can use the nuclear energy in many fields in our life. We use this nuclear energy in medical field, in agriculture field, in industrial field, in electric generation field, in space exploration and drilling field. Nuclear energy has a great importance in medical field as it used to diagnose and treat diseases like cancer and many different diseases. Number two, we can use the nuclear energy in the agriculture field to eliminate pests and to improve some plants. Okay, eliminate pests means kill them. We can use the nuclear energy in another field, which is industrial field. The nuclear energy in the industrial field used to convert sand into silicon sheets. These silicon sheets used in manufacturing of computer processors. Okay, and the processor of a computer is considered the brain of the computer. Okay, so the nuclear energy has a great importance also in the industrial field. We can use the nuclear energy to generate electricity inside the nuclear reactor. How we can generate the electricity inside the nuclear reactor from the nuclear energy? The nuclear energy is used to heat water to produce a huge amount of steam. This steam is used to operate turbines. These turbines can generate electricity. Okay, so now we have four uses for nuclear energy in medical field, in agriculture field, in industrial field, and in electric generation. Number five, nuclear energy can used in space exploration, as we can use many radioactive elements as a foil for the rockets that fly in the space, like the satellites. Okay, number six, we use the nuclear energy in drilling field for drilling of petroleum and underground water. So now we have the peaceful uses for nuclear energy in six different fields. Number one, medical field, agriculture field, industrial field, and electric generation field, space exploration, and finally the drilling field that is used for drilling of petroleum and underground water. And now we have finished explaining the first part of lesson 3. We talked about the radioactivity phenomena, radioactive elements, and the peaceful uses for nuclear energy. We will complete the second part in another video. Wish you all the best. Mr. Mahmoud Shirbini, your science teacher. Thanks.